If you remember back to first learning about lines in algebra class, you remember that your instructor spent a lot of time talking about the three ways that lines can be drawn in a plane. So way number one, which is the most interesting to us, is they can intersect. That's always fun to do because then your instructors force you to find the point of intersection. Good times. But then the lines could also be the word we saw in the previous example, which is parallel. So if they're parallel in traditional Euclidean geometry, it means they will never touch. They will have the same slope and they will just keep climbing in the same directions but never meet. All right. I should put little arrows. These are lines. So, although technically they could be line segments as well, so it doesn't really matter. All right, then the third way would be if they were colinear. So if one line and the other line are actually the same, right, that's colinear. All right, all three of those possibilities still exist in 3 dimensions. I mean, 2 dimensions is part of 3 dimensions, so I just drew them. There they are. But there is a third possibility as well, and that's skew. Okay, so what does skew mean? It means that they're on parallel planes, but they're not parallel themselves. All right, so let me draw a couple planes here. Draw one plane up high and one plane down low. It's like they're 2 floating sheets of paper. And then I have one line that goes this way, and I have another line that goes that way. They're never going to meet because they're on these parallel planes, but they're not going in the same direction, right? One's going one way and one's going the other. So that's what skew is. They're not parallel, but they're never going to intersect. So they're not going to the same direction. So that's what's happening. So they're not parallel, but they're never going to touch. All right, so let's see here. Given 2 equations, or equations of 2 lines in 3 dimensions, how can we determine those relationships? Well, there's 2 basic cases. You can have it so, now notice, the v is the direction vectors. See those? So just make a little note. I'll put it right here. Note. Because of the location, v1, v2 are direction vectors. They're the 3-dimensional vector equivalent of slope, right, for lack of a better term, right? It's what we learned in algebra classes, slope, but now it's more powerful than that. It has direction, it has a vector attached to it, it's 3-dimensional instead of 2-dimensional, and all that business. But in the end, it's kind of serving the same master. It's telling us the rise and the run, for lack of better terms. Okay, so if I look at those direction vectors, it's possible that v1 is just some multiple of v2 or vice versa, right? So v1 could be twice v2, or v1 could be a half of v2, something like that. Now, if that's the case, then there's 2 possibilities. The lines are parallel if there's no intersection point. They'll never meet. No intersection point. Or they're colinear, in which case there's infinitely many intersection points. I feel bad. I shouldn't quite abbreviate that much, so let me actually put the word in here. Intersection. If I could spell it right. Point. There we go. Sorry, I had a little dog fur in there. Okay, so if you look, these 2 have the same direction. So it's possible they're parallel, or it's possible they're colinear. This one would never have an intersection point. This one would have lots of intersection points, right? So if you find one, you know there's more. So those are the 2 options if they are moving in the same direction, if they have the same direction vector, more or less. All right, what if they don't? What if v1, the direction vector for v1, is not a multiple of v2? Well, then there's two options. They either intersect, which means there is an intersection point, or they're skew. Actually, let me match these. I take it back. Let me do it this way. That way they line up. Skew is when there's no intersection point. Right? So no intersection point, there's skew. Intersect rather obviously means that there is an intersection point. All right, let's put it into practice. Let's do some examples, shall we? Okay, so here we go. We have to determine whether the following lines are parallel, colinear, intersecting, or skew. And I think that's a typo. There should only be one L in colinear. There we go. It's not there. I couldn't make it disappear. Okay, so let's look. Now I got rid of both of the L's. That's not good. Colinear. All right, so if I look at my direction vectors here. So direction vector 1, V1, if you will, is 3, 2, 3. And V2, put it right below it, is 1, 2, 3. All right, well, there's no way that I can multiply one of these by a constant and get the other one. Like, that's not going to work because 2 times 1 is 2, but 3 times 1 is not. So V1 is not a multiple of V2. So that means that I'm either intersecting or skewing. Those are the options. That's what's going to happen. Okay, so we need to find the intersection point if it exists. So let's set this up. Okay. If it's going to exist, then there would be a spot where 3t take away 2 would be equal to negative 6s. Oh, sorry, s take away negative 6. Sorry, I read that wrong. Sorry about that. I don't have my glasses on, so it's my own fault. So s take away 6. Similarly, 2t would be equal to, so 2t plus 0 would be equal to 2s take away 8. And 3t would be equal to 3s take away 12. And we are not going to do this by hand. We are going to use Maple to do this. Okay, so in Maple, there's this lovely command called solve, and it's wonderful. So I'm just going to do these for all of these so you can see them. Okay, so what you do is you plug in solve parentheses, and then in curly braces, you put in your system of equations. So curly bracket, and then 3t minus 2 equals s minus 6, comma, then the second equation, 2t, oh, I think I did it wrong, 2t equals, see, I was typing, 2t equals 2s minus 8, and then 3t minus, or equals, see I was typing too fast, equals s minus 12. Oop, minus 12. All right, so double check everything because it's weird. It doesn't look like it does on the page exactly. So 3t minus 2 equals s minus 6. 2t equals 2s minus 8. 3t equals 3s minus 12. And then close that parentheses because that's the end of your system of equations. And then you put a comma. And then you tell it what you would like it to solve for, which is t and s, those two variables. So I put a curly braces in, say t comma s, and I close my curly braces. And then I hit enter. And it takes a moment. But it tells me that it finds, you can see it in small print right there, s is 4 and t is 0. Done. So I know that s is 4 and t is 0. So there is an intersection, and it would happen at those parameter values. So we're just going to say solve command, and I'm just going to type this, 3t minus 2 equals s minus 6, comma, dot, dot, dot. So comma, parentheses, t, comma, s. I'm not going to write this all the time, but this is a one-time thing, so you can see how these work. And when you do in Maple, it tells us that the answer is t equals 0, s equals 4. So that means that there is a point of intersection. Right? Since we found this, that means they are intersecting. Now, where do they intersect at, right? So if we have to find the intersection point. So what you do is you take either one of these. Either you take 0 and put it into R1, or you take 4 and put it into R2. Either one should work, right? So R1 of 0 would be -2, 0, 0, right? Because if you put 0 in for t, it's just going to make the whole thing disappear, and you're left with that point. R2 of 4, for the record, would be 4 take away 6, right? Because 4 times 1 is 4. 4 times 2 is 8. 8 take away 8. And then 12 take away 12, which indeed is -2, 0, 0. So you can see it doesn't matter which one you go with. It's going to be intersecting at, now these are vectors. The point would not be in vector notation. It would be parentheses -2, 0, 0. So these are vector forms of that point. They're really from the origin to that point. All right, now what about these ones? Well, it just kind of keeps working the same way. The only thing is that these ones have a little bit trickier time finding that direction vector, because the direction vector is the t component, of course. So the v one, I should say, v for direction vector, would be equal to 1, -2, and 3. v2 would be equal to, you look in front of the s component, so -7, 14, -21. Okay, now look, v, if you will, v2 is -7 times v1. So let's note v2 is -7 times v1. Or if you like, v1 is -1/7 of v2. Either way. Okay, so that means that our options are going to be parallel or colinear. Those are going to be the two options for us. So all we have to do is write down the system of equations and get Maple to solve it, and life is grand. So to find the intersection points, if one exists, it'd be t plus 4 equals -7 s plus 1. The nice part about this is that when they're written in this form, it's real easy to figure out what your system is because it was already written for you, essentially. That j component equals that j component, that k component. Oh, and that must be a k component. Sorry, that's a typo. Let me fix that. Yeah, that's a typo. Sorry about that. Okay, so that k component, which is 3t plus 1, equals that k component. So I'm just going to go type this in Maple. and see what happens. All right, so I've typed it all in. We're all set to go. I'm going to hit enter, and nothing happened. Oh, what's going on? It's because there's no solution. So when there's no solution, it looks like Maple's not giving you an output. And that's because there isn't one to give, because there is no solution to this. So you haven't done anything wrong, but you have to make sure you type everything correctly. So Maple shows that there's no solution. And if there's no solution, that must mean the lines were parallel. Okay, so let's do the last example. All right, again, we have to come up with our direction vectors. So if I look here, direction vector 1 is 5, -2, 3. Direction vector 2 is 10, 4, 6. And these are obviously not multiples of each other, right? So V1 is not a constant multiplied by V2, nor vice versa, right? So that means that we're either intersecting or skew. And if you know the way a math professor works, you know this is going to be skew. But because we already did an intersecting example, but let's prove it. Let's do this. So we're going to solve the equations. So we're going to say 4 plus 5t equals 10s. We're going to solve with Maple. To find the intersection point. Oh, I guess I should label that the way I did. 1 second. Sorry, we're finding the intersection point. We are going to solve it with Maple, but that's how we're going to do it. So 4 plus 5t equals 10s. -2t equals 6 plus 4s. And then 1 plus 3t equals 4 plus 6s. And then we solve with Maple. We just make a note of that. So I'll go type all that in and see what happens. All right, so I've typed my values in, and I'm going to hit enter. And it did it again. There's no solution, right? So I didn't do anything wrong. It's just not coming up with a number, and that's because there's no answer. So again, I solve with Maple. There's no solution. And therefore, these lines are, just as I said they would be, skew. Intersecting would be if they had an intersection point, but there is no solution, so they are skew.